The Nuclear Talent Show is a long-format interview. NuclearTalentBoost.com contains straight-to-the-point lessons that we don't include in the show. We have forums and discussion spaces where you can ask questions to colleagues to help with your current job and get credit from our clients for your participation in a way that shoots you to the front of interview lines. All this and more for free in exchange for your resume and job preferences, which allows us to save your time by only reaching out to you about states, rates, and dates that fit your desires, unlike so many other recruiters. We can place you directly in-house with our clients or as a staff aug contractor. You sharing this video with your colleagues helps them obtain life-changing jobs and helps us keep making this amazing content. So please repost and share our videos. Trey, you used to be an industrial engineer at the University of Florida. They've got a really good nuclear engineering school. You've got this fancy new AI tool that's going to help all the nuclear engineers in the world solve the nuclear paperwork crisis so that they can go on to solve the energy crisis and all this. So please tell me more about yourself and your widgets and all your hopes and dreams.
Oh my goodness, Russell. Well, quite the introduction. I will have to say, once an industrial engineer, always an industrial engineer, and definitely once a Florida Gator. I got my Florida Gator memorabilia there. I got a bunch of it all over the place. So once you're a Gator forever. But appreciate the time. Maybe before we jump into AI applications and what we're doing and the potential for artificial intelligence to substantially improve workflow and paperwork in the nuclear industry, maybe I give a little bit of background on myself and kind of introducing newer technologies to more legacy markets, because I think that'll give us a good foundation of why I believe this opportunity is just so absolutely exciting and just really once in a lifetime. So would that be okay to maybe shift
Excellent.
direction a
Please
little bit?
do.
So by background, you are correct, Russell. I industrial engineer from University of Florida. Ended up going into healthcare IT really back in the early days. About 15 years ago, in 2008, I started a company named Volt. It was the first company that brought smartphones into hospitals to improve clinical communication. And when I say that, people kind of turn their head and they say, Trey, what does that even mean? Like, what else would people use besides a smartphone? And I always have to remind people that back in 2008, I don't know, I'm sure some of your listeners were probably in elementary school back then. Back then, the iPhone and Android devices, they weren't pervasive. It wasn't known that iPhone and smartphones in general were going to be everywhere. And actually, the standard device was the BlackBerry. Like everyone in the enterprise had a BlackBerry. So when I used to go tell hospital administrators, nurses, doctors, hey, your nurses and doctors should each have iPhones. And those iPhones should be able to access the electronic medical record. And you should be able to do video calls and receive alerts and see critical FDA information on these devices. People used to think I was crazy. Literally, I would get walked out of hospitals saying, Trey, the future is BlackBerry. What are you doing? My nurses and doctors would never text. Why do you even have that feature? Things today that are just obvious because smartphone technology is so pervasive were not obvious back then. And I think that's a really important point, because as you look at the parallel to artificial intelligence, when we start discussing the application that we've built today and our future ambitions for other applications, some of this might sound a little far-fetched and it might sound like a reality that might not come to pass or might not come to fruition. But when you enter, especially in what I'd consider enterprise companies, enterprise markets that are slow to change, in many cases, these transformational technologies, it takes a while for them to pick up. But when they do, workflow is changed quite substantially, and it enables a tremendous amount of innovation and improvement. So my background, again, I started a company bringing iPhones into hospitals in 2008. We learned so much. I mean, at that time, I was 25. I had no idea how to start a company. We got really lucky and we had some great customers. We had some great investors. And by the time we sold the company to actually a hospital bed manufacturer in 2019, we had a number of the leading health systems across the US all using the platform, hundreds of thousands of nurses, doctors. So we were really the standard for enabling doctors and nurses to communicate using smartphone-based technology. So from there, I spent a couple of years at Hillrom, which I actually wear the hat of, which was the hospital bed manufacturer that acquired us. I ran the digital business. We then sold that company a couple of years later to another medical device company, Baxter. At that point, I exited large companies and I spent the last few years really focused on angel investing, venture capital, private equity, board positions, fractional executives, mostly in healthcare IT or digital health. And it was all about artificial intelligence, introducing and bringing AI into the healthcare ecosystem. And that's really when I discovered, AI has been around for quite some time, but really the last like 5 to 10 years, AI was more in the research and development phase. It was academics publishing papers, and it was all sorts of kind of foundational technologies that really weren't ready for the prime time, weren't ready for mission critical organizations. And what I witnessed a few years ago was a number of these AI applications were actually mature to the point where they could have substantial impact on mission critical workflows. And some examples were I got to support a company that was using computer vision, basically computers being able to see things to help radiologists spot different type of cancers way before the human eye could be able to see it. So like really incredible outcomes of AI. Another company, which I absolutely adore, was using automatic speech recognition to help providers document, think about your primary care physician, document the patient provider encounters that occur. So that's a fancy way of saying when you go to your doctor and they're at their computer typing away, putting information in the EMR, it's not a great experience. Like you want the doctor to focus on you, pay attention to you, really be engaged with your health. But it's hard because they have to document all this. So they have one of two options. They either will listen to you and take notes, and then when you're done, spend 30 minutes typing it in, or they'll type it in during the encounter. Both experiences, not fantastic. So there was a company I was supporting that built a series of AI as automatic speech recognition. It can record the patient-physician encounter, then use AI to transcribe that, create the physician's note, put it in the EMR, and it had like insane accuracy, like 99% accuracy. And it also spoke like 25 languages. So as I'm sure you're aware, like medical, really big, complex words. And the fact that AI could pick that up, it was just breathtaking. And there were physicians that would say like, Trey, I can practice medicine again because of this technology. It gives me 2 hours back a day, which is a lot of time for our doctors and nurses who are just burdened with all this documentation. So put all that together, AI is becoming real, seeing it applied in mission critical industries. And by this point, you're probably saying, all right, Trey, well, what does this have to do with nuclear power? About 3 years ago, I moved to San Luis Obispo, California, which is a beautiful place, Central Coast. We got 8 and 5-year-old boys, want a nice community to raise our kids. And we happen to live 10 miles from Diablo Canyon, which is California's last nuclear power plant. And if you live in a town, a small community that has a nuclear power plant, you quickly realize that the employees of that power plant are an absolutely key component of the local community. Run into nuclear power engineers all over the place. One of them was the coach of my son's basketball team. I'm a naturally curious person. So I would always ask like, oh, you work at Diablo Canyon. Tell me about your day-to-day. Tell me how power is created. And as you know, when you meet people in nuclear, they're excited about nuclear. They like to share their experiences and, quickly learned from these discussions, the science of nuclear power is a modern day miracle. We discovered how to split the atom. And as a result of splitting that atom, we could create heat. And then we found a way to harness that heat to create energy in a safe, efficient format that doesn't release carbon emissions. Modern day miracle. However, there has been a tremendous amount of red tape and bureaucracy that has been put on top of this fantastic technology. So as I was learning more and more about some of the challenges that nuclear faced, this last Thanksgiving realized and decided this was an area that I was really excited about. And this was a place I wanted to focus all of my attention. So ended up leaving healthcare and starting Atomic Canyon with the goal of taking the lessons learned and some of the really fantastic kind of science behind AI and finding ways to apply that in the nuclear power space to help across the board, to help with regulations. And over time, we'll release other applications, but it's all about harnessing this really transformational force AI and figuring out how it can be leveraged in a safe, effective format to help our nuclear power industry continue to evolve. So that was a really long story, but that's kind of the background that led to the starting of Atomic Canyon and kind of why I'm so excited about the opportunity.
No, that was a great overview. The thing that I really love about you coming into the nuclear industry is that, the FDA and hospital environments in general, like that's just a ton of their own red tape and their own labyrinths of paperwork to get through. In recent episodes of the podcast here, we've been going through how the NRC is a federal agency, and there's plenty of other federal agencies doing a lot of other paperwork. And so the fact that you were able to take AI and get it into the healthcare system is certainly not child's play. When I look at Atomic Canyon versus other startup AI companies that maybe have never actually run that gauntlet in any industry before, it makes me hopeful that you're in our industry now trying to get the same things done.
Well, Russell, you can actually break that into a couple different buckets. Starting first from a pure technology perspective, hospitals are very similar to nuclear power plants in that they're very risk adverse, as they should be. Literally, the job of the hospital is you have something horrible happening in your life. You end up in a hospital. The nurses and doctors, who are just absolutely incredible humans, are there to save your life, like literally save your life or fix your broken arm. So very risk adverse. And they're not the types that are just going to try new technologies on a whim. Very similar to nuclear, where if something, heaven forbid, went wrong in a nuclear power plant, there's tremendous ramifications. So both organizations have that overall thought process of, do no harm. And we must be very, very pragmatic in how any type of new technology is deployed. You kind of have the overall philosophies and values, which are very much aligned. And then from a technology perspective, things that matter in hospitals, security, making sure that patient information is not leaked, or there's laws called HIPAA, which is all about protecting patient information. Nuclear is very similar. Cybersecurity, reliability, a lot of on-premise solutions. So many industries have gone full cloud. Everything goes to the cloud. Hospitals and nuclear power plants might be two of the last that still like servers on site. So knowing how to install servers, provision servers, not have cloud solutions, all of those skill sets from a technology perspective transfer really well. And I'd say separately, the soft skills are equally as important. I'll give an example of one of my favorite lessons learned. Again, when I was 25, we had the iPhone. Some of the first hospitals we engaged with, I'd go and maybe meet with their innovation department, and we kind of would agree, we're going to deploy iPhones, we're going to integrate all of these mission critical alarms. For example, like a code blue. If you stop breathing, there's always a blue button in a hospital room. You hit that and it sends an alarm across the whole hospital that someone has stopped breathing. Rapid response, huge issue. So we're going to integrate that, all these mission critical systems. And then we went and talked to the users, the nurses and doctors, kind of explaining what we wanted to do. And they looked at us and said, "Are you freaking crazy? We are not ready to trust mission critical code blue alarms to this iPhone, which I think of as a toy for Angry Birds." And that's when we had a lot of lessons learned, where as a new technology, the onus is on us as the technology providers to earn the trust and the respect and the validation from the users. So you don't start with the most challenging mission critical application. For example, you don't start with the code blue patient monitoring alarms that are life critical. We started with simply text messaging, building a directory so you could get rid of a phone and pager and be able to text someone by role or give them a phone call by role or by name. Very simple application to start. But what that does is individuals and nurses and doctors were able to see, hey, this actually works. I text someone, the text goes through. And then eventually, as you build the trust of the workflow and you save people time, you then add on and layer on the more mission critical applications. So for example, when we integrated the code blue, they used to have a pager, physical pager that they would carry that was code blue pager, and they'd carry an iPhone for texting and voice calls. To start, we sent the alarm to both devices. So they still had the code blue pager, and they got to see, in many cases, a code blue would be hit. You'd hear all the smartphones make an alarm, and then 5 seconds later, you hear all the pagers make an alarm. So people then realize, wait a second, this thing works perfectly fine. And a week later, there are a bunch of pagers in a drawer, and you've earned the trust to move forward. The parallel in nuclear is, I tell people we're going to bring AI into nuclear, and immediately you get a lot of like, whoa, what are you doing, tech bro? Like, calm down, no way. And what we explain to people is we're not coming and saying artificial intelligence is going to run your nuclear power plant. That would be insane. Literally the plot of Terminator, like AI and nuclear get together. We're not saying to go there by any means. What we're saying is there's a very specific problem in nuclear power, which is we create a tremendous amount of documentation due to regulatory purposes. And in many cases, your nuclear power plants, they can't find data. They can't find information. And there's many organizations that suffer from this. So what we're coming forth and saying is, let us use AI to help make it so you can more easily get access to the data you already have, which then enables tremendous amounts of time saving and workflow. It's also not a mission critical application, because if we can't help you find it faster, you just go to your more traditional ways of searching or asking the individual who's been in engineering 40 years where they keep the documents. So it's not like this mission critical app to start with. Search search and finding information becomes a very foundational layer and use case of AI that adds a lot of value, but also enables us as an AI company to establish trust with the industry and with the users. And from that foundation of trust from a technology perspective and from a workflow perspective, we can then look at layering on additional sets of artificial intelligence capabilities, which add more and more value. And yes, maybe become slightly more risky with each turn, but we'll be very, very thoughtful and careful, engaging all the regulators and engaging all the kind of security, compliance folks to make sure as AI is deployed, it's done in a safe, reliable, usable format.
Excellent. I like that iterative approach. Your approach, it would seem, is to, as you said, you want to get people a widget that builds trust with them and that gets a useful, non-mission critical thing accomplished. And it sounds like you're trying to do that with this thing called Neutron. So
Yes.
do you want to speak a bit more about that? This free widget that you're going to give us that's going to make us trust you and get all this stuff done for us.
I think instead of the word widget, I think
Yeah.
a better way to think of it is it's more of a foundational platform, and the first application off that platform is Neutron. But maybe stepping back, when you look at AI and you tell anyone like, hey, what do you think of AI? Immediately people go to ChatGPT. People think about OpenAI and ChatGPT and chatbots and what's referred to as generative AI. So you can go to ChatGPT and say, hey, make a 90s rap song about nuclear power making a comeback in the United States. And like magic, ChatGPT will create it. It's like super fun. And then you go to Dolly or other places and show me an image of a beautiful nuclear power plant producing clean energy. And like, oh, it's a crazy image. It looks awesome. Everyone's become enamored with generative AI applications. So when we engage, what we notice is a lot of people ask us, hey, Trey, can you in Atomic Canyon, can you go build a ChatGPT for nuclear? Can you build this incredible intelligent agent that tells me any bit of information that I want to know instantly? And it's super reliable and safe, and it doesn't hallucinate. And hallucinate is the fancy way of saying make stuff up. So AI, if you go to ChatGPT, it'll tell you at the bottom, like, hey, just sometimes this isn't accurate information. And as you know, in nuclear, accuracy is quite important, and hallucination is very, very bad. So kind of as we sought out, we launched our company in November, and we have a lot of humility as we enter the nuclear space. Myself, and I brought Christian Kielhoffner, who's our chief technology officer, and he's my co-founder. He's probably one of the top 10 application developers in AI. Like, he is phenomenal. So brought him into the space as well. And as we were evaluating what's the strategy to move forward with AI and nuclear, where do we go? What do we do? We first went and downloaded from the NRC, the Nuclear Regulatory Commission's website. There's a website, Atoms, which has all sorts of public information about every nuclear power plant. We downloaded all their documents, which is about 52 million pages of documents. We then put together a series of artificial intelligence to use computer vision, automatic speech recognition, etc., to understand what's in all of these documents. What do the words look like? What do they mean? And we put that in a database and then made it so you could search that database using a more kind of modern-based front end versus the NRC Atoms website, which is a little bit more of like a Boolean-based search. So it made it really easy to search that application. That's totally free, available to everyone in the nuclear industry. We do ask you to sign up just because we want to make sure that no foreign actors or anyone who might have something negative to do with nuclear, we don't want anyone like that to access it. So we do have a little bit of a firewall just to keep it safe. But as we were building this application and experimenting with AI and nuclear, we quickly realized one of the biggest problems with artificial intelligence in the nuclear space is AI hasn't seen enough nuclear words to understand what they mean. There's abbreviations, there's words. Some abbreviations have multiple meanings. So there's a lot of work that needs to be done around the context of words and what they mean before you could build any type of generative application. To tackle this problem, you need a supercomputer. This is the type of training that you would need to go spend tens of millions of dollars to buy a big computer to run really advanced AI training. We did a bunch of research and we got connected with Oak Ridge National Laboratory, which is home to Frontier. Oak Ridge is one of the DOE's labs, happens to be super specialized in both nuclear and AI. So as we met with them, it was a match made in heaven. We were provided an allocation to use Frontier to train not an LLM or a generative AI app, strictly what's called a sentence embedding model and a series of sentence embedding models. So that's a fancy set of words to say we're teaching AI models how to understand nuclear words. And this product, which we should have available in September, October time period, we're actually going to open source that. So what that means is all of that output of the sentence embedding models and this foundational piece of AI, which we believe is necessary to help the whole industry of nuclear power use AI, we're going to make it totally free. We're going to publish our code. We're going to publish the training data, the outcomes, our performance, everything, so anyone can use it at absolutely no cost. From there, we take those sentence embedding models and put that into our Neutron search platform, which makes it way easier and better and more accurate when searching and finding information in the nuclear power fleet. So we believe the first series of customers that will find value will be nuclear power plants. Across the board, we've been in numerous discussions and we have multiple engagements underway where US nuclear power plants have billions of documents. And our tool, we plan on taking an enterprise version of it and putting it on premise, understanding and ingesting their data and helping them just find documents. And that's kind of the first phase of Neutron and what we're really focused on today. And then we have a roadmap of where we take this over the next few years that does include generative applications. And you can start to really blue sky just tremendous amounts of opportunity for AI to help multiple workflows in the nuclear power space.
Yeah, I think the challenge with training an AI to speak nuclear is that there are just so many different dialects, right? It can be really tough for even long-time nuclear professionals to jump from one dialect of nuclear to another because every company has its own language and every different area of the nuclear industry uses different words for basically the same things. And then there's those really scary times when they use the same word for very different things. So let me give you an example that doesn't even address international versus American or sodium reactor versus gas-cooled reactor or DOE versus commercial. This is just the very narrow example of how even in the American operating pressurized water reactor industry, there can be so many synonyms that cause so much confusion across different plants. The three major vendors in the current American operating fleet, Combustion Engineering, Babcock & Wilcox, and Westinghouse, they all have different names for the same functioning equipment. So Combustion Engineering calls it a safety injection tank, but Westinghouse calls it a cold leg accumulator. And you can imagine the lifelong Combustion Engineering plant person walking into the Westinghouse plant for the first time and just having a heart attack to hear that there aren't safety injection tanks, right? And at NuScale, which is a pressurized water reactor too, I would witness these lifelong pressurized water reactor people come in and have similar heart attacks to hear about all the different components we didn't have, and components that we did have but just called a different name. And yeah, I mean, sometimes the NuScale safety case was just that radically different, so I'll cut them some slack, but there was also a ton that was just a matter of synonyms not being recognized. NuclearTalentBoost.com is putting together a lot of great decoder rings and translating tools and other little things that help operating reactor people transition into the advanced reactor community, and non-nuclear people transition into nuclear, and nuclear people that just want to get better at their jobs. Because the percentage of new employees that rage quit because of the different nuclear dialect communication issues is not a trivial fraction. This happens all the time where people will just rage quit their new position because they just can't seem to communicate well with their teams just because they're talking boiling water reactor language to a gas-cooled reactor person. So that's what Nuclear Talent Scout is doing to address this really big staffing issue today. And I'm really looking forward to your own AI platform tools at Atomic Canyon to, in the future, get us to the point where, just like how your smartphone will translate in real time between English and Spanish, a DOE nuclear person can talk to a boiling water reactor person just like that. And I really look forward to that. Yeah, when you tell me that one of the fastest supercomputers in the world is just going to be burning through all of these nuclear documents and learning and getting smart, I'm just sitting here more worried about that computer blowing up and catching on fire from just getting so overloaded than...
Yeah, well, so luckily, Frontier is literally the world's fastest supercomputer. So I think it's pretty exciting. And, every day we're just humbled that we get to work with that Oak Ridge team and that we get to leverage this incredible investment that the US government has made through the Department of Energy at Oak Ridge. And we're doing it for a really novel purpose, which is helping AI understand nuclear. And again, we think this is such a foundational piece of AI technology. We want to provide it open source to the entire industry, whether that's people that might compete with us down the line. That's great. Like the bottom line is when you look at nuclear power, this is without a doubt the best potential source for clean energy for our country and the world. And AI, I know it sounds kind of far-fetched. We're in the very early phases of how artificial intelligence will improve and transform workflows. So making sure that nuclear power has the right tool set of AI capabilities that are custom designed for this specific industry will be just absolutely paramount to enabling other AI parties to come in. It's going to take an army of AI companies coming in to help all of the different nuclear power. I mean, just think about it. You got your current nuclear power fleet. You've got nuclear power plants that are being recommissioned both domestically. I've heard discussions, about recommissioning in Japan and other locations. It's like turning back on our previous nuclear power plants, helping our existing fleet run more effectively. And then you transition to net new builds. And there's a tremendous amount of excitement around, hey, we built Vogtle 3, Vogtle 4. Yeah, they went over cost, but we learned a ton. How do we take those learnings and just apply them to build another 30, 40, 50, 100 AP1000s? And then you've got the SMR revolution. So you've got, dozens of SMR companies that are all racing to get approval. Some of them have approval from the NRC with the passing of the Advance Act. Bipartisan support, 88 to 2 yays in the Senate, which is unheard of. So now you've got a transitioning regulatory landscape, which can be more favorable to getting new designs approved. So suddenly there's going to be all these different SMR technologies, and there's definitely deviation from all these different vendors, whether it's the Oklos, the NuScales, the Xterra, Terra Energy, all of these companies have very different designs. So how those get built, how they get regulated, how they get licensed, big projects, and a lot of work there can get automated with artificial intelligence. And as those plants come online and they're suddenly live and they have to be managed, and we're suddenly talking about building 10, 20, 30, 50 AP1000s or the equivalent that GE has, the ESBWR, those big guys eventually, they'll get lit up. Then you get all the SMRs just domestically. That's a huge amounts of projects. Then as you go international, you have different languages, different regulatory environments throughout all of Europe, throughout emerging countries in Africa, in South America, in Asia. Just the matrix of the amount of engineering, documentation, regulation, all of that has AI applications. And that's just one modality of artificial intelligence. We're just talking about words right now. As you start to think about other modalities and other advancements that will occur in areas such as computer vision, the idea, and again, this is going to sound a little far-fetched, that the construction worker that's working on, the next AP1000 that will hopefully be going right in my backyard or 10 miles from my backyard, when they come in to start their shift, putting on, Apple Vision Pro 5s or 6s in 4 or 5 years. And those have computer vision that see what that construction worker is seeing every day. And then they have a little microphone and they have a little speaker in their ear. And there's an AI agent that's telling them, okay, today we're doing work order 734. I'm looking, lay the concrete like this. Great. Acknowledge that has been accomplished. Great. That is now stored in the record management construction system. On to the next task. All of these workflows, as you think about the intersection of augmented reality, mobility, cameras, plus computer vision, plus automatic speech recognition, where a worker is not going to need like an iPad or a pen and paper. They're just going to talk, and the computer agent will be able to guide them in their workflow. All of this, if AI technology stopped advancing today, we could still build this. I don't need the AI technology to advance any further. We need to keep fine-tuning it, and we have to keep aligning it, but the AI technology could stop where it's at today, and we could make that vision a reality. As the AI continues to improve, it's just going to get easier and easier, and the workflows are going to become more exciting. So, you talk about that. That's probably like 4 or 5 different companies that are going to tackle different parts of this. And that's why a lot of the work we're doing today is putting a lot of the AI nuclear specific foundation in place. And maybe one last point in that is there are going to be a lot of AI application companies. Take this incredible AI science and just go apply it. We're going to do a lot of that as well. But what really differentiates Atomic Canyon is we are also a leading edge AI research and development shop. So some of the work we're doing with our sentence embedding models, this is going to be best in class kind of AI development that is necessary for the nuclear industry, but it can also be deployed across multiple other industries. So I think that's a big differentiator is we're not just the application of the AI, AI, we're also very much equipped to be a research and development arm, which I think is quite unique about our company. And I've learned, again, in nuclear power, we think in decades. So we're in this for the long run.
Yeah, that's great. Just imagining, for example, in a test laboratory or when you're receiving equipment, using some sort of visual AI through a camera that, will just check whether this nut has a crack in it, check if a weld was okay, and all these sorts of things. These are all like in the future things that certainly in our AI utopia will be happening. But like, I love that you're starting with like just the immediate need of, hey, like grandpa built a bunch of great nuclear plants. He wrote a bunch of documents about it. We sort of lost it. It's hard to find and interpret these. So let's start there first and then train our AI with that first task.
Oh no, your point, there is definitely a generational transition that's occurring in nuclear power, which is one of the reasons I'm so excited to be on talking to your group at the Nuclear Talent Show, because we do need to educate the next generation. A lot of these plants were built in the 50s, 60s, 70s, 80s, and it started to slow down after that. And a lot of the workers might be preparing for retirement up in age, 50, 60, 70s, and they've been in nuclear power for quite some time. And they hold in their brain a tremendous amount of tribal knowledge and information that they've learned through their many decades of experience. It feels like the Gen Z and some of the younger millennials are really excited about nuclear. I can call them the youth because I'm 42, but I talk to the kids these days.
Go for it.
And there's just a tremendous amount of excitement around nuclear power. They're not tarnished with previous views, and they can bring a very objective view to this technology. So you've got the younger generation that's embracing it, but there's a bit of a chasm we're going to have to cross. There's a canyon here where you've got a generation of more experienced workers who are going to be retiring. There's going to be attrition. And then you've got the younger generation who ideally we need to pass that knowledge on. And I do think artificial intelligence can be one, not the only, but one of the key technologies that helps bridge that gap and helps the younger generation of workers become more effective and more confident in what they're doing. But then also, equally as important, offload some of the work of the generation that might be moving into more of a retirement phase of their career. That way, they don't feel like they're, the single thread, that they're having to work 80 hours a week because they're the only one with the answers. What I've noticed in nuclear power, very similar to healthcare, there is an unlimited amount of work. You go to visit a nuclear power plant, people are not just, sitting around twiddling their thumbs. There is an outage to plan for. There is improvements that are to be made. There is no lack of work to operate and to improve. So that's what gets me excited is, can we use AI to make it so more people can get more work done with less amounts of time? Because I think there's just tremendous value to be captured in enabling these workers to really work to their pay grade. And that's a lot of what we're going to be focused on.
That's great. And definitely, I think that at a certain point, it's like just whether you have the document or not. A lot of the new generation coming in, they've gone to engineering school. They know how to do thermodynamics, but don't know the exact document number in the document set that's going to tell them the exact calorimetry of this plant or whatever. Whereas usually like the about to retire guy, he just knows off the back of his hand that like, oh yeah, like document 17283 is where we keep that. But the new guy doesn't know. And like just getting to the point where you can just be like, oh, key search term for calorimetry and it pulls it up, but it's like,
and well, it's building beyond that. It's funny with Adams, the NRC Adams website, we call it Adams Kung Fu. There are people that know how to like enter all these words, like move stuff around, and they got really good with the tool. Similarly, in every nuclear power plant, there are individuals who've just been there forever. And it's funny, many times they download files to their computer and they like tag it on their computer. We've seen some really wacky workarounds and workflows as we've been engaging with multiple nuclear power plants on how they manage these documents. So you are spot on. There is definitely just opportunity to help bring some of that tribal knowledge into the mainstream. And again, this is just the first application we're building. From there, once you can search and find documents, the ability to start generating first round drafts off of these and helping to facilitate more advanced workflow, we think is going to be super exciting. And we think it's going to create a lot of value for nuclear power plants and next generation construction opportunities.
Awesome. The whole open source thing, I'll call you computer nerds seem to do this open source thing a lot, right? Linux and ChatGPT in general, it's like for some reason the computer nerds always do open source stuff. And like, I've run Fortran and stuff and different nuclear codes, but like, I don't consider myself a computer nerd. But anyway, all you computer nerds do all your open source stuff.
Yeah. So it's funny you say that. My co-founder, when he listens to this and hears that you call me a computer nerd, he is going to laugh because in his eyes, I am the farthest thing from a computer nerd, but I take that as a compliment for sure.
Excellent.
And from us, I'm glad you brought that up. In a very ironic sense, the nuclear industry, and again, me being newer to this space, the nuclear industry has very much the ethos of open source. And let me explain that. So you've got the Nuclear Regulatory Commission, and they gather information from every plant, and they have it all publicly available. Why do they do that? For transparency and for everyone to learn from one another. And one of the first lessons I learned in nuclear, speaking with a nuclear power plant site lead, I asked her, why is it you guys share so much? Healthcare is not like that. It's funny, healthcare is incredibly political. You might have a hospital that's a large academic medical center, and it's next to a pediatric hospital, and they're like competitive, they don't share stuff. Healthcare like very much becomes a very competitive industry, a lot of egos. I haven't seen any of that in nuclear. In fact, I've seen the opposite, where everyone is just willing to help out, lend a hand. It is a really phenomenal industry to be in. And what the nuclear power plant administrator shared with me is she said, Trey, an accident at any plant is an accident at every plant. So everyone here is open to sharing data, sharing information, helping to educate the masses because it's all one industry. And if one plant has an issue or a problem that becomes serious, the ramifications are felt worldwide, not just domestically, worldwide. As a result, you have the Nuclear Regulatory Commission, and the data that they're receiving is being shared with everyone. That same mentality of transparency and a community is better than any single individual is the same ethos of open source. So as we develop and release parts of our platform that are open source, it is our signal to the nuclear community that we are giving back. We want to help everyone. And it is our hope, and usually the way that the open source environment works is there will be other AI companies that will grab our code and will start to use it. And in any code, there's always going to be areas for improvement. There will be bugs to be found and fixed. So the whole concept of open source is when you put this body of work out and people use it, there's almost an unwritten rule where if you're going to use it and you improve upon it, you give it back to the community. And as a result, you end up with this ecosystem that helps make the code better, more transparent, and more visible to the entire population that will use that product. With the sentence embedding models, again, teaching AI to understand nuclear, super foundational. And we hope many companies will use this code to kind of advance their causes. As a result, we hope they then contribute back and then contribute to a product that we can then use in our application. So it becomes very much a procedure of the community and transparency are better than kind of hoarding everything by yourself. So that's kind of the thought process behind that.
No, that's glorious. You'll get people having their proprietary submittals to the NRC, right? And so like everyone's still got their patents and whatever, and that's fair, right? At least I'm a capitalist. I believe in intellectual property and stuff. But at the same time, right, it's like a balance because, a lot of the push for nuclear energy is that like, hey, either through lack of energy and the energy crisis in general, like us running out of oil or something, or natural gas not being cheap anymore, or through the aspect of carbon emissions are going to like make the planet uninhabitable or whatever. Either one of those paths gets you to like, hey, we as humanity just need to solve this energy thing and through nuclear as fast as we can. And we don't have time to be like miserly keeping information from each other. We need to like, come together and hold hands and share information and achieve a thing. I think it just really is a big testimony to the practical reasons of teamwork tends to create a better product anyway with transparency, but also it shows where your heart is, right? You really believe that nuclear is the solution and that there's real dangers of not solving this. And so open source, right? And that's what we're doing at nucleartalentboost.com as well, right? We've got this very large training academy growing, and we've got lots of people on our website giving these trainings They're essentially like instructors who you could go pay like $1,000 or more to like listen to an equivalent instructor talk about the same things, maybe even worse, but we're just giving it to you for free because the nuclear talent shortage is real and it's probably going to be the biggest thing keeping us from making nuclear. And so open source, right? You just have to give us your resume. But
Yeah, no,
yeah.
and look, I think there's a balance to everything. Just like in life, there's always balance. So, from our perspective, there's kind of this foundational set of technology, the AI itself and the training of the AI. A lot of components of that should be open source. But as you look at the application of that, going to a specific nuclear power plant, when we install the NVIDIA H100s, kind of the CPUs on site there, all of their proprietary data will not be intermingled with the public data. Our view is you use the public data to create a tool set, create the AI, then you take an instance of that and you put it on site against their proprietary data, and that information lives all on site. Very secure. There's a lot of confidential information. So it's a big scenario where you have a tool set that's public, that's available for everyone, but then when you go to deploy it in the enterprise, you make sure to respect and treat with the utmost security there's a specific set of information that you can keep safe and keep confidential. So there's definitely elements of open source in what we're building, but then separately making sure there's a product that is very secure, mission critical. So as with everything, there is a balance to do this properly.
Yeah, and I love that you already have all that experience. It's not your first rodeo in terms of like people would get pretty upset if their medical records were suddenly on the internet or whatever, right?
Exactly.
When I was working at Shine, they're a medical isotope producing company in Wisconsin here. That was sort of my first taste into FDA and, CGMP sorts of requirements. And yeah, it was honestly like a lot. There were certain little aspects of our plant here where there was the nuclear paperwork, and sometimes that was like a trivial amount compared to the FDA paperwork that we had to do. Obviously, when you've got a product that you're injecting into people, people care about it.
Yeah,
Yeah,
absolutely.
that's really cool. So I, for example, have been helping your team a bit in terms of test driving Neutron and telling you guys when it's producing amazing results and telling you guys when it's hallucinating and stuff and sort of helping to train it. And I believe that you guys are open to other nuclear experts coming in and provide the feedback to your models to help it be better for everyone. So if someone was interested in doing that, how would they sign up and get in touch with you?
Yeah, a couple ways. So number one, you can always just email me directly, Trey at atomic-canyon.com. Separately, you just go to atomic-canyon.com. There's a little button there, try Neutron, and hit us there and sign up. We absolutely, anyone in the nuclear space, we want as many users as possible. We do ask for a little bit of feedback to kind of help us with training, etc. This is the first iteration of the product we've released. We have the major release that includes our sentence embedding models coming out probably September, October time period. So you'll see a substantial improvement in the product then, and then we'll continue to improve it going forward. But yeah, we see this as a tool to help all those in nuclear power, 100% free, not going to charge for it. This is our way of just giving back to the community and helping people find information. So yeah, please encourage all of your listeners to engage with us, reach out. While we are new to nuclear, we absolutely love it. As I kind of joke around, you guys are stuck with us. We're going to be in here for decades. And it is our vision and hope that AI gets to play a foundational role in unburdening some of these nuclear power plants from either how they currently exist or from being built. So yeah, we think there is no more important technology than nuclear power. And we think AI is the best tool to help really enable nuclear power to meet its full potential. And the ramifications of that are just incredibly exciting. I mean, it's clean energy for the masses that's really cost effective. And we're going to get there. It's going to take some time, but we got a lot of great entrepreneurs in this space, and there's a change in the air. You can just feel the energy. It's very exciting.
I concur. It's definitely never been brighter days here at Nuclear Land. It's funny. I had like a whole course on nuclear law. So one of the foundational stones of it was why Chevron deference matters and how it affects you and your life interacting with NRC. And then right before I sat down to record it, Chevron deference got overturned by the Supreme Court. So I had to like go rewrite a bunch of stuff. And then now I had a very in-depth how to use Atoms, web-based Atoms library to find different documents. And that's still very helpful and people can watch it. But then like I just heard about Atomic Canyon. It's just like the supercomputer is going to make Atoms obsolete. And I was just like, no, come on.
Well, just to clarify, we have no intention of making Atoms obsolete. We love the
Yeah.
NRC. We could not have done anything that we're doing without them digitizing the documents. So we really don't view us as like, hey, we're trying to like compete with the NRC.
Yeah.
Our goal is to build off the shoulders of giants. They digitized all this data, they made it available, and that investment that they made enables us to do what we're doing. So, we are huge fans of the NRC because our company could not exist without them. And Adams, look, it serves its purpose. We see ourselves as very complementary. We love the NRC, we love what they're doing, and we're very thankful for everything that they put together.
Yeah, and I think Neutron in its current rendition, and I imagine you'll keep this feature going forward, it provides traceability to like the accession numbers of the document that it's pulling information from, and a lot of other like tiebacks to Atoms. So all that time I spent making the Atoms how-to videos and Nuclear Talent Boost, they're going to stay relevant for a while, so you should all go listen to them.
Listen to that. Listen to all the episodes. So everything you got is fantastic.
Thanks a lot, Trey. Well, let's all pray that all this amazing new AI technology actually simplifies our lives instead of making them even more complex.
We will make sure that happens. You got my word on that, Russell. We'll make it work.
Thanks for all you're doing for our industry. I mean, again, just all the open source stuff. I really can tell where your heart is, and it sounds like you actually have the brains to pull it off too. So I'm excited to see what happens. And
it is all the team. It is all my team. I appreciate being called the computer nerd. The real computer nerds, and I'll use your term, they're on my team and they make it happen. I just get to have the privilege of help facilitating them being in the right place to be successful. That's my job as a leader.
Awesome.
We hope you enjoyed the show. We're helping solve the energy crisis for our children and the world by addressing the nuclear talent shortage. Please help us by liking, sharing, and subscribing, registering on nucleartalentboost.com, and telling your human resources and procurement departments you'd like to work with nucleartalentscout.com for all your staffing needs.